Today what we're going to do is a demonstration that's sometimes referred to as Mom to the Rescue or milk of magnesia. Now, what is milk of magnesia? Sometimes you might have seen it in the stores. All right, true milk of magnesia is actually magnesium hydroxide. Right? Now, magnesium hydroxide, if you look at milk of magnesia, here's some that's already been measured, you see that it's a thick white, almost solid looking liquid. All right? So what it is actually magnesium hydroxide. A little bit of it is dissolved. Most of it is still solid, and it's in what's called a suspension instead of a solution. So what we're going to do is we're set up two beakers here, all right, and we're going to add to both of them. There's some ice in the bottom of both. We're going to add to both of them this milk of magnesia. Now you'll notice some of it's sticking to the sides. So what we're going to do is we're going to use some distilled water to rinse these down and get as much, if not all, of the milk of magnesia out of there. All right. Now I don't have a stirring rod with us, but we'll rinse this a couple of times with distilled water to get as much of milk of magnesia into each as we can. Now we'll add some more distilled water. And we have two solutions of milk of magnesia. Right? So all that's in there right now is water, milk of magnesia, and ice. And the ice is there for one purpose, which we'll talk about later. Now, what I'm dropping in is what's called a stir bar. It's a magnet that is attracted to the magnets that's in this hot plate. This is a hot plate stirrer, so it has both purposes. And when I turn that on, it'll cause the water to be stirred, as you can see. And we'll get them both stirring at the same rate. So notice I'm being very careful to make sure that everything is the same. I made sure that the amount of milk of magnesia in each is the same. I made sure about the same amount of ice. We have about the same volume of distilled water. Now, the next thing we're going to do is add this thing called universal indicator. Now, universal indicator changes color through a whole range of values. It doesn't just change color at one specific point in the pH scale. It changes all through the pH scale. So we're going to add one good squirt of universal indicator to this one, and one good squirt of universal indicator to that one. And you can see that it's very strongly purple, which says that both of these are very strongly basic at this point. All right, it works its way all the way from bright red when it's acidic to very dark purple like this when it's basic. Now it's not as dark a purple because we have the white milk of magnesia. I'm going to take this off stage so it doesn't mess with your color perception. Now, what we're going to do is we're going to add acid. In this case, we have 6 molar, very strong concentration, acetic acid. And in this case, we have 6 molar hydrochloric acid. Exact same concentration, just 2 different acids. Now, I want you to watch and see what happens. So I'm going to add 5 mils of each. This one over here is the acetic, this one over here is the hydrochloric. You see a very strong color change in both. This one's, well, that was interesting. This one went from red to peach to this green, while this one is still very much peach. I wonder why. Let's watch them for a second or two without me talking. Now notice the one on the left has turned almost blue. So it's getting more and more basic. The one on your right is almost yellow, so it's almost neutral again. So the one on the left is almost purple again, and the one on the right is now almost green. So what's going on? Why did we use the ice? The only reason I used the ice was to slow this reaction down. Had I done this with warm water, this would have happened very, very fast. But as you can see, this container is now back to the purple that it was, so it is again very strongly basic. And this one's almost back to the purple that it was, so it's mostly basic as well. Now, what we're going to do is we're going to add 5 more mils of each. Again, this turns bright, almost red, and this... Why is this one so fast and this one's so slow? This one's already almost neutral. It had strong acid in it, and yet it's almost neutral. This had a weak acid in it, and yet it's still acidic right now. What the heck is going on here? While you think about that, I'll load these up for another run. Okay, so our strong acid solution is now very much basic again. Our weak acid solution, reacting with the magnesium hydroxide, is now just about basic. It's very strange. So let's do it again. Okay, bright red, except it's in a white solution, so it's not real red, but now it's green. Very strange. I wonder why that is. Think about the reaction that's occurring. The magnesium hydroxide, the hydroxide, is reacting with the H's, the acid. And that's making, what would H from the acid and the H from the other acid, what would they make? Well, H and OH, HOH, 2 H's and an O, H2O, so we're making water from both of these. This is the rest of the acetic acid ion. This is acetate ion. This with hydrogen makes hydrogen with acetate ion or acetic acid. This is HCl, which makes hydrochloric acid. And they're both back to blue, so let's do it again. Notice that one turns bright red. Oh, there it goes. It's going back. And again, the strong acid is turning basic more quickly than the weak acid. What's going on with that? I want you to try to think about why that would happen. Remembering what I just said, the hydrochloric acid and the acetic acid are both reacting with the OHs and making water. Which one might react faster? And why does it go back to basic? Well, we must have something else happening here. There's about 2 or 3 different reactions happening here. So this one, notice it's almost basic. It's not getting as purple as it was before. And this one's getting towards green. So this is getting basic again, and this one's getting basic again. We'll give it a couple more seconds. One more dose. Well, this one's staying red a lot longer now, isn't it? What's keeping this one red when it wasn't red before? Oh, maybe you noticed something else happened. What do you see? Well, look at that. This one no longer has any cloudiness. This one no longer has any solid magnesium hydroxide. And so this one is now staying red. Just by comparison, if we take a little bit of universal indicator and put it in with just the HCl, by itself, it makes that pretty red. And if we take a little bit of the universal indicator and put it in with the acetic acid, notice it's not as red. It's a little more peachish. This one's strongly acidic. This one isn't as acidic. We'll give that another couple seconds, see if it clears up. And it should. It's just going to take a lot longer. Because remember, we put almost the exact same. Now, it might be a little off because our measurements weren't perfect. Or there might be a little amount of magnesia stuck in here. But we put the same amount of milk of magnesia in both. We put the same amount of acid in both. But we get a different reaction rate because we're using a weak acid and a strong acid. And just to prove to you that it does go, we'll just add a little more acetic, just a tiny bit, in case we were off a little bit with our milk of magnesia. And we can stop this one. That's a little better. Probably should have done that at the beginning, shouldn't we? Hopefully you can hear all this. If not, I'll just talk over myself. I'm used to that. Okay, so you'll notice that once this starts to clear up, we'll make that stir really fast. I can stick my finger all the way in there and not get wet because there's a vortex. We'll just speed this up just a touch more, just to make sure. There we are. It's starting to clear off. Now, ordinarily I'd wait, but since this is a video and I don't want you to have to watch a 15 or 20-minute video, we can stop soon here, and you'll notice that this one is never going to turn. That's a neat noise. This one's never going to turn as bright red as this one, even though it has more acetic acid in it. There, it's starting to clear up. Give it another couple seconds. Okay. And so if we come back to this a little bit, what you'll see is that this one is totally clear as well, because all the magnesium hydroxide has reacted, but it will be a much lighter shade. It won't be as bright red as this.